Welcome back. All right, let's wrap up this section about network protocols by going back to some of these other protocols that we haven't talked about yet and just looking at, again, all the other types of data that we may be putting across a network and what each of those mean. We'll start by looking at QDP, which is Q-SYS Discovery Protocol. So this is the method by which Q-SYS devices can talk and identify each other across a network. Essentially what happens is a Q-SYS device will constantly send out a request looking for other Q-SYS devices. So the core does this, the designer software does this. About every second, it just sends out a little query onto the network that says, hey, anybody out here also a Q-SYS thing? And anything that is a Q-SYS thing says, hey, me, I'm a Q-SYS thing. I want to be a Q-SYS thing. I live right over here. This is my IP address. And this is how, when you open up Configurator in the software, that's how you see all of the devices on the network, even those that aren't within your subnet range. Because we are sending this information out via UDP multicast, much like the PTP we talked about. So here you've got a core that's sending out its information saying, hey, I'm a core, and every other Q-SYS device that is on the network that receives that multicast request then sends a unicast response back to the core because the core identified itself and its location when that happened. And then the core keeps this list of all of the Q-SYS devices, where they are, and that's what you can see in Configurator so that you can actually talk to everything. So sometimes if you're not able to find a device on the network, it may be that something is restricting the multicast, for instance, and preventing QDP from going out and getting that information back to the network. And that may be something that you may need to then investigate at the switch level. Use something like a PCAP device to figure out, hey, is QDP being transmitted properly? We'll talk a little bit about things like that in the next couple of sections. Once again, that packet goes out every second from the core, from devices, from the software itself, and then they subscribe to the multicast group that wants to basically say, hey, we are Q-SYS. Keep us in mind whenever you're asking what Q-SYS devices are out there. So that's QDP, Q-SYS Discovery Protocol, very important. Let's go back and take a look at some of the other protocols that we use, something like the control protocols. We talked about using TCP for control protocols, but we also use HTTPS for control protocols. The HTTPS, you've seen that at the top of every website you've ever gone to, right? This is a known, reliable method that two devices can use to communicate back and forth. And we use that between devices as well. When the core wants to talk to control devices, whether it's a UCI view or a touchscreen controller, that may be taking place via HTTPS. And that takes place on TCP port 443. There are some other ports that are very important with other control protocols that you should keep in mind as well. If you're using Control Binary Secure, QCBS, that's going to be used in different core redundancy situations. That's going to take place with TCP port 1704. If you're using External Control Protocol, ECP, which is a real simple protocol for third-party devices to communicate back and forth with the core using basic ASCII characters, that takes place on port 1702. Whereas you could also use QRC, which is Remote Control Protocol. That takes place on port 1710. That uses JSON command prompts, so that is a different protocol as well. All of these different ports are going to be pretty important because there's an area in the core manager where you can enable different ports, and you may actually want to disable ports that you're not using. That'll make your IT department pretty happy. But we've got to make sure that the ports that you are using are enabled, so knowing why you would be using those ports could be pretty important. And also, keep in mind that control traffic is not a lot. We're not flooding the traffic with control. Control information is 10 megabits per second or less. This is not video packets. This is not even audio packets. This is going to be pretty small as far as your bandwidth goes to control various devices. Let's talk about video streams using RTP for video delivery. So our encoders use RTSP server to stream the video, and that means that the receiving devices are going to use TCP back to the sending device to say, hey, I want this particular video stream. And then it will receive that video stream via RTP. That means that the actual connection is point to point. The core itself is not receiving that video coming in and then sending it out after processing it. That's not what's happening. The core is just managing the devices and how they will send to each other. So no video streams are transported to the core and back again. Instead, the core is more like a traffic cop. where it says you're going to go there and you're going to go over there based on the needs of each of those devices. So those are all either unicast or multicast. That does mean that if the sending device is only going to a single recipient, then it could be a unicast video stream. Whereas if it is going to be sent to multiple end devices, it will actually automatically tell itself, hey, I know this needs to be multicast. But you can configure that manually in the Q-SYS Designer. As far as bitrate goes, as far as the weight of this traffic on your network, well, this is significant. Video streams are big. That's also the main reason why we don't want it to go all to the core and back again, because if you have more than one video stream on the network, that would be more than the core can handle on its upload. So you can use 650 megabits per second for a 4K stream. That could even go a little bit higher. You can throttle that. That's for a 4K stream. You can see immediately why we can't do 2 4K streams on a gigabit system, right? But you could do up to 3 1080p streams from a single network device, because 1080p streams only use 250 megabits per second. 3 of those is 750 megabits per second. That's still within our range of bandwidth that's possible for that device. So keep that in mind, and remember, you can configure that as you are choosing it as well. And the shift codec, if you're not familiar with that, that will automatically throttle the amount of bandwidth that is being used based on the actual content itself. If you're showing something really static, like this PowerPoint that has no pixels changing from second to second, then the shift codec will throttle it back and use less bandwidth. Whereas if you are in full motion video, then it'll use the entirety of that bandwidth that's available. And then finally, let's talk about camera streams, which are very different than video streams. Camera streams are actually H.264 encoded streams. They are multicast with this particular range of multicast addressed. The main camera stream is a user configurable bitrate between 1 and 30 megabits per second. And it also has a preview stream that you can access, and that can be sent to a touch panel or UCI viewer. And that is also H.264, and that is user configurable between half a megabit per second to 2 megabits per second. Okay, so that's a good look at the majority of the protocols that you'll need to know when configuring your switches, and a little bit of the background on all the different ways we transmit audio, video, and control across the network. So let's take a break right here, and in the next section, we'll talk about how to configure your network switches so that all of these protocols will actually work properly. Take a quick break. We'll see you in a bit.